A lot of my students ask me how to work out the gradient of a function without making silly mistakes all the time. So I made this video for them. In today's video, we'll take a look at how to calculate the gradient of a function graphically using 3 simple examples, while in my next video, I explain how to get it using calculus, that is, differentiation. So let's get started. The first thing we must know is how to calculate the gradient or the slope of any graph. If you're asking why we must memorize this, I have explained this in detail in the previous video, which you can check in the description, so no need to memorize. So let's take a look at example number 1. Calculate the gradient of the graph given to us. We start by choosing 2 crispy points on our graph. Say we imagine it's a hill we are climbing and we want to work out the distance we have covered. Well, obviously we will subtract the distance at the beginning from our final distance. In this case, distances are a pair of x and y coordinates. So, say we choose point A and B as 2, 2, and 6, 6. It will be really easy to work out the gradient by simply substituting in our formula and then working out our final answer. The gradient in this case would be 1. Okay, let's take a look at example number 2. Calculate the gradient of the graph given. So, once again, we have 2 random points on our graph, and then we annotate them as 1, 4 and 2, 2. Then we can substitute this into our formula once again, subtract the values, and get our gradient as -2. But then we have to make sure that the order in which we subtract is always correct. This is why I see a lot of students making mistakes. So what you can do is to simply write down x and y, then you align each of these points underneath the x and the y. Next thing you do is circle up the y coordinates and then the x coordinates. Since the y coordinate is in the top part of our formula, we can easily substitute it in there and then we subtract to get our final answer. Example number 3. It is worth noting that some curriculums use the notion of rise over run. I'm going to explain in a bit. So, for you to work out the gradient, you can use how many times you rise over how many times you run to get from one point to another. In this case, the formula would just be rise over run for our gradient. Let's take a look at the green graph. We're going to choose 2 random points, say C and D. Now we need to calculate how many times we need to rise and run from C to get to D. So if I rise 1 time, I may need to run 4 times to get to D. So in this case, my gradient, which is m, would just be 1 over 4. Considering the blue graph, we can see that it is sloping downwards. So instead of rising, we are going to fall instead. For this notion, let's keep in mind that rising would give us a positive gradient, but falling would give us a negative gradient. I guess that's just basic common sense. So we're going to choose 2 points once again, A and B, and then we're going to see how many times we need to fall from A to get to B. Okay, so since A is 5, 0, it means we need to fall 5 times, and then we need to run 1.5 times to get to B. Since we're falling, don't forget our gradient has to be a minus. So we're going to get -5 over 1.5. Then we can simplify this using our calculators or just the basic knowledge of fractions. And we get our final answer as -10 over 3. What if the graph of a function is not given, but its equation is given? This will lead us to another way of calculating the gradient of a function, which is by differentiation. This playlist is on differentiation and you can watch it over here.